Hello everyone, welcome back to Texture Expert. Today we continue to analyze and design uh, torsion or beam resist torsion in Graitec Advance Design 2023. Now let's start. Click on configuration, change the localization to France. Click OK. Now we use in a French language or design report and design report in French language. Click on the language interface language we use in the English. Click OK. Click on new. OK. Click on new. I call it curve beam design, curve beam in Graitec Advance Design 2023. Next and finish. Click close. Click on the by 3 point. Click center, click first point and click second point and input number of side. Now I input the number of this curve of the curve beam is 30 and select all the lines. Click authority, convert line to linear object. And I want to delete all this help line. Okay, now you check we model it in asset plan. You can move it by select all beam, click on home, click on move and rotation, click first point and axis. You can input the angle 90 degree. Click on preview. Okay, minus 90 degree. Move. Click on top view. Active working plane. Shift middle key for rotation. Now click on all of beam. Click on select all beam. Change the material to 30. Change the dimension to 400 millimeter multiplied with 1000 millimeter. Sorry, 400 millimeter. 400 millimeter multiplied with 1000 millimeter dip of the beam and click on the concrete cover. Now we want to keep the concrete cover in default is 3 cm. Incline exposure is 0. Here you can change the angle of strut in the default software, in the tape, in robot, in Graitec Advance Design. All of the software use the same default strut angle is 45 degree for the maximum. For the critical they use shear angle, strut angle 45 degree. Actually this strut angle can be lower than or smaller than this value. Now you can check in my tutorial. You can check my tutorial I post on February 2022. How to design concrete beam, combine torsion, moment and shear. I explained you in the 3 tutorial. You can check it for the basic concept to verify with a tab and menu. You can check about the 3233. It includes design for the torsion, moment, and for the shear force. We designed it in a tab version 20 and compare with the menu result, and we discuss about this result. You can check on this tutorial. Now we focus about design torsion in GED 23. After you click, you select all beam, click to active beam design, okay, to calculate beam, and escape. You can create a super element. Click all beam, super element, create. Now it's become one element when you use the option. Click on curve beam, create new load. Now you can click on loading, create several case families. Input one. You input one for the load case you want to active. If you don't want to active, you can keep the value 00. Now we want to active the load and line load. Click create the load and line load. Create, select all beam, click on line load, right click, load on selection. The value of the distributed load is minus 2 kN per meter length. Auto scale. See here middle key. You can select and check the magnitude or load is correct. And for the line load, I want to use this copy from the line load to the load. Select control copy, select this load and pass. Double click to hide line load, select all the load and change the magnitude to 3 kN per meter length. Okay. Now after complete for modeling and apply load, don't forget to assign support. In this case, you must assign fixed support to make the frame stable in plane and out of plane. If you use pin support, the structure or this frame is not stable. Must assign fixed support. Okay, fixed support. You can escape and click on wireframe mode to view it in wireframe. Now create load combination. Right click property, simplify combination, generate, yes, okay. Create envelope. You can create envelope load case. Property, force, max and min case. Select all. Okay, apply, close. Now after you complete for modeling, you can continue to analyze and design. And for the analysis design, we will discuss about analysis and about design results. Compare with the Excel sheet. Click on the analysis. Click on OC design. Click OK. click on the displacement, click on load combination, check visibility, turn off for the planar element. In the frame we have only linear element. You can select on the for processing. The maximum deflection is 4.3 millimeter. You can click on value on diagram. Again, you see the value show in the diagram is 4.3. Okay, 4.3. See here in middle mouse. Use the animation. Click on animation. Escape. Click on force. You can view force by one case to one case. You can view for the dead load, light load, ultimate load combinations, visibility. Now in the case I want to show the maximum force. When you envelope force, you can show maximum and minimum force. I don't know how many cases. Example, we create a combination 50 combination, so you don't know which one is the maximum and minimum result, so you can create envelope. It is very easy. The envelope will show the maximum and minimum all of the load combination that you want to include in the envelope. You can check about model, and we click on the property and you select locate. So where will be envelope run, check for the maximum all of those load combinations, and come back to analysis. Click open the current analysis models, and now click on the linear element. Click unwind for the bending moment. Maximum 313.8 at the support, and minus 137.8. Now click on the emit for the torsion. Now we want to focus about the torsion design in Graitec Advance Design 23. This middle mouse for the rotation. The maximum value is 125.1 kilonewton. Is it the force maximum value? And for the MY bending moment measure axis, and bending moment minor axis, axial force, shear force. Asset is the shear force. Now click on the MX torsion, torsion in beam. Now you can click on the reinforcement. Click on the AL is the torsion rebar. Click the torsion rebar maximum at the support is 14.53 square centimeter. For this section, you can select and check this section is 40 multiplied with 100 centimeter. Or the cross section area, or the cross section rectangular. AZ is the longitudinal reinforcement at the bottom and at the top, and AY is the reinforcement. I want to explain you. Snipping tool. This is the section of beam. This is the reinforcement top and bottom. This is the reinforcement AZ. Okay, when you show the AZ, you can check AZ at the top and at the bottom, at the top, at the bottom. And AY is the reinforcement in this direction. What indicates reinforcement in this direction is not required. No need. We need only reinforcement AZ, top and bottom. And for AL is the reinforcement for torsion. Reinforcement for torsion, we will focus on the corner 1, 2, 3, 4. Here you cannot use the rebar diameter larger in your project, so you can use a smaller rebar and distribute it like a column. You can add more rebar, add more rebar at the side, so it work to receive for the torsion direction. Okay, you can arrange the rebar like the section or column. Use the similar concept. This for the longitudinal rebar, and for the shear we also use the same. For the torsion, we use the outside link is the main link. Okay, outside link, I call it outside link or outside stirrup. It receive for the torsion. You can check for the torsion. It does torsion flow in this direction. So the outside link is very important. You must to do the outside link larger up to 10 mm or 12 mm to receive for the torsion, and with the maximum spacing and minimum spacing. And for the internal link, you can design it to receive for the shear. Okay, I try to explain you, and for more tutorial about this design 3, you can check this 3 part: beam receiver, torsion, shear, and moment. We design it together, the 3 force design in a tape compared with the Excel. It is my Excel. We input moment, torsion, shear, and axial force. And you can distribute it rebar to receive for the torsion. This section cannot receive, you can add more rebar. It works like a column, okay, to receive torsion. Or you has another option to increase the section of the beam to receive for the torsion. You can increase torsion. You can increase section of beam, or you can use more rebar in a section. Which one option is available for you? You can select one. If you want to keep the section or the dimension of the beam, you has no other choice, so you must to add more reinforcement and increase the reinforced concrete strength or strength of concrete to keep your section as the minimum. In case you can increase your section, you should increase your section and use smaller diameter rebar and a larger spacing of the shear reinforcement. It is easy to install and put in concrete in construction site. Now come back to Graitec Advance Design. We discuss about the reinforcement design. Click on the reinforcement, click on the AL, reinforcement for torsion. Now come back to my Excel sheet. It is a small Excel sheet. Check for the internal force. Click on beam to check the dimension of beam. 40 multiplied with 100 centimeter. 1 and 0.4. SAK is 30 megapascal, and the yield strength of rebar is 500. In the default of software Graitec Advance Design 23, yield strength of reinforcement is 500 megapascal. 500 megapascal is strength of rebar in European country. If your local area you lower value, then the yield strength you can input and correct it in the option. Click on the reinforcement, click on the material and property. You can change it, the value or rebar yield strength to 400 or 420. $125.1 125.1 125.1. This is the requirement of the torsion rebar. Is 14.7 square centimeter. Now show the result is 14.54 square centimeter in Graitec Advance Design. This is for the Excel sheet. It different around 0.16, okay, 0.16 square centimeter from my Excel sheet. and this is for the shear series torsion. In the Graitec Advance Design, it can be used in the shear along a Z axis and shear along Y axis. And you can check the software we use the default setting. The software we use default settings start angle 45 degrees. Almost of the film software today nowadays use the same. The maximum angle 45 degree default to calculate to design for the shear reinforcement, to design for the torsion reinforcement. It use the same, use E45 in default, and you can change it. You can check with my tutorial about how to calculate this angle, how to calculate when it has a combined for torsion, shear with the moment,